All right, let's get into today's lab. The good thing is that we've already done a huge amount of the work to be able to have a deployable model, right? At the end of the day, we've already created our API. We have designed it so that we can have anyone send some hands that they want to analyze and for which they want to get some probability that they're going to win. So pretty stable state already, but the only thing that we are missing is that instead of serving this data locally, go into a local file, look for a local model, run the processing of the prediction locally, and then serve back the data locally. Like instead of doing that locally, we want to put that online so that everybody can access it. And that is exactly what we're going to do with Google Cloud Functions. As always, you can follow this lab here that I have put in here. If you have access to the content, you should be able to open this lab and go for it. But this is what we're going to be talking about today, so stick with me and let's get started. So essentially the first step is going to be to refactor our notebook code into a script. As always, because we are going to deploy this on the cloud technology, we need to have a properly refactored script that's going to be able to be shipped online. So what we're going to do is we're going to head to our material content and we are going to open the serving pipeline here that is inside of the model folder. You should always download this MLOps material so that you have access to the script. And what we're going to see here, we're going to see how we can refactor the script and we're going to see how we can ship this refactored script to Google Cloud so that we can serve the model as a serverless deployment. And so the first thing that we are going to do is we are going to include in this script like all of the stuff that our model is going to need. And this includes, first of all, a reference to the feature converter endpoint. Like we're going to need our serving pipeline to know where is the endpoint, like where is the API that allows us to go from raw features to clean features, right? This is exactly what we are including here. Second of all, we're going to give it the bucket name. This is where we are storing things like our production model, right? And it's pretty interesting because this is exactly the location where MLflow is storing our model. Like when we launch a training pipeline with MLflow, we're essentially saying store our model on Google Cloud Storage and everybody can have access to the Google Cloud Storage. So here, what we do in this serving pipeline is we create a pointer to the latest production model that we have deployed with MLflow. And we just say like, hey, this is where the actual model lives. So if you want to serve this model, if you want to predict some new data using this model, just go look into this Google Storage folder and just retrieve this model.pkl. And that's what you're going to need to do the predictions. So this is the pointer. Obviously, if we rerun, for instance, the MLflow training pipeline, and we create a new model that we want to put into production, we're going to need to change this path here so that it points to whatever latest model in production. And we can know what is the latest model in production because as we saw last time in the MLflow lab, we saw that to make it clear for everybody what is the production model, you kind of like flag this model in the UI and you point, like you basically say like, hey, this is the model that in production. And so you can just go back to the MLflow interface, go to the production environment and grab whatever model has been deployed in production. This is what we've done last time. And so we put that here so that we have access to the latest production model. We're also going to give it like the model name. This is so that we are able to access the model afterwards. And we are going to manually say what are the covariates that are expected for this model to be able to predict our new data. And again, these covariates, I've written them down manually. These covariates, again, come from the signature that I found in MLflow. I found in MLflow a signature that was telling me like, this model expects this input so that it can create a prediction. This is exactly what these covariates are here that I got directly from MLflow. And now what we're going to do is we are going to create a small utility that is called getProductionModel. So this is very straightforward. Instead of reading a model in our local directory on our local machine, essentially what we do here is we have to go to our storage facility and we have to retrieve from this storage facility the model that is in production. And so This is a little bit of input-output that we do, and we play around with Google Cloud Storage by getting access to the bucket, reading the blob, and then getting the production model directly out of Cloud Storage. So this is kind of a way to retrieve the model without using interface that we have for Google Cloud Storage. So this is using directly a Python client to play and manage these resources here that are stored in Google Cloud Storage. And so once I have this defined, now what I can do, well, first of all, I'm going to include this clean feature in here as well, because we need to clean the feature as they come in. This is exactly the code that comes directly from the notebook. We need to include that in the script as well. Same goes for the build extra feature. This is something that I'm going to include in the pipeline as well, because this is something that I need for the serving of the model. And finally, the main dish for this lab here is the use of this serving method. So essentially, because now I am moving away from a local deployment that I do with Flask, because we are moving away from using Flask to serve our model manually and locally, and we are moving towards a serverless architecture through Google Cloud. Well, our Google Cloud function precisely is going to enable us to create a small wrapper, like a small function called serve model. This is very similar to what we have done here. But instead of creating a Flask route so that we can serve data at a specific route and allow people to access it through the browser or through anything, we're just going to create a wrapper, like a function framework that comes directly from Google Cloud Functions. So this is a small utility that Google Function allows us to use. And basically what this function framework is going to do is it's going to allow us to define a post request. It's going to allow us to access a request which is going to contain all the inputs that the user sends us. And we're going to be able to access this to generate the prediction on top of this input. And so what you're going to see inside of this function here is very, very similar to what we have defined together in here. The only difference is that we're just using another framework to be able to serve this data online and doing it at scale with everybody being able to access it. So what we're going to do here is we're going to do exactly the same code that we have done earlier in the previous module, in the live coding session. The only difference is that now, instead of looking in our local folder to access the local production model, we are going to be looking inside of the Google Cloud Storage facility to be able to retrieve the production model. That is the only thing that we're going to be doing different here. And then we're going to predict the probability of winning, and then we're going to give back this probability to the user that tries to access it. So all of this is very, very similar. Now, the big difference is that we are going to be using Google Cloud Functions to deploy this serving pipeline here and to create a function called bullet model serving. And the way we're going to do that is by basically just calling here this Google function deploy bullet model serving. And essentially what we're doing here is we're saying create a new serving of this model, this Gen 2, because there was Gen 1, and Gen 2 is, I don't know, some kind of like slightly more improved version of this product that Google Cloud is providing us, this function product. And we're going to say that the runtime of this function, in other words, the way that we're going to run things inside of the server where this code is being hosted, is going to be Python 3.8. Now, for those of you who have a little bit of experience with engineering and stuff like this, you might be wondering, why have I been calling this whole thing a serverless architecture, or in other words, an architecture where there is no server? Why have I been calling that a serverless architecture if at the end of the day we do have a server that hosts the code, and this server has a Python version installed in it so that it can run basically the whole script? Well, this is where the name is a little bit of a misnomer. Essentially, it's not because it's called serverless architecture that there is no server involved. There is always a server behind the scene where the code is running. That's always going to be the case, that code is going to be running on the server. The only thing is that we don't have to manage this server. If we were to deploy things locally with my notebook here that I created, we are essentially the one who need to manage this server. Like, we're managing my own local computer that is the one that is serving the model. We need to make sure that my own local computer has the right Python dependencies, has access to the model, is up and running all the time. So I'm going to need to let my computer run and be alive forever. If I want people to be able to access this model all the time when I serve it locally like this, I need my computer to just stay awake nonstop. Here, like, we have to take care of none of that because we are deploying this script inside of a server that we don't manage at all. And we're just saying, take this runtime, take this memory, give it like 1 gigabyte of memory so that it can function. But obviously we don't give it more because it doesn't need to do a lot. It needs to run a very, very small model. It needs to serve the prediction based on this model. If we had like a huge model with billions of parameters and billions of, a lot of things like this, then probably we would need to give it more memory. But because now we are predicting one sample at a time and we have a very small model that has very few weights, we don't really need more memory than this. And we're going to be hosting this in Europe, region West 1, which is probably like Belgium. And we're going to say like, okay, here is the repository, here is the stuff that you have to run inside of the server, and here is the entry point. Like, the entry point is basically when somebody is asking to use this model, this is basically what a Google Cloud function is going to look into serve model, and is going to see whether it can run this code in here automatically. So this is exactly what serve model does. And we're going to create a trigger. The trigger here is exactly what allows us to pay only for only for runtime. We don't pay for uptime. In other words, we don't pay for the time that the server hosting this code is up. We only pay whenever somebody triggers a run of this code because somebody is trying to access the underlying models. So that's exactly what this does here. And then we're just saying that everybody can access this stuff. And this is exactly what we want. We want everybody to be able to access this model and make requests. And then we launch these gcloud functions. So, if you already have a function, like a deployment that is running, like it's the case for me, then you can just like launch this command. So we're going to delete the currently running deployment. And then you can take that and run it like this, and this launch a new deployment. So now let's go through this. Let's say that I don't have a deployment that's running and I just relaunch a new one. Let's see if it's gonna let me do that, because I already have one running and I don't really want to delete it because it's gonna take some time. So let's see what happens now. I'm trying to redeploy a function. Okay, so let's assume that we have launched this and we have created a new function. Now we can look at this function and we can see what's going on with this function. It's pretty cool. We can see how many times it's being invoked. So we can see how many people are using our API here, how many times there is any invocation per second. We can see we had a spike because I was like trying it out a few minutes earlier, and then we can see that it stabilized down, and we can see pretty much everything we want. We can see the execution time it takes to run this serving of the model. We can see the memory usage that it's going to take for the server to serve the model and things like that. And then we can look at a bunch of more things, like if something goes wrong, we can look at the logs that the script has produced, and we can test also, let's say, this API, especially like during testing phase. We can see how the API is working and whether we need to improve anything. And so to wrap up the example, let's say here that, okay, I have deployed now my function, and now I want to try and see if it works. So now that I have deployed it, it tells me that the ballot serving API is available here through HTTPS, ballot serving, then this code here, and then this app. So we should be able to access the model here. Well, obviously, again, we cannot access this model through a web browser, right? Because what we have defined here in our script is we have defined a post request that needs to receive some kind of input, and based on this input, create the predictions. So if we make a GET request through a web browser, we're not going to get anything out of this. Like, it's not going to be very useful. And in fact, we can see that this request that we just did here has been registered through the Cloud Function service. And we can see that in the logs, we've tried to do a GET request of this HTTP ballot model endpoint. And obviously it didn't work because it was not defined and we could not basically access any data. So what we can do, however, is we can grab these endpoints and we can go to our old friend Postman. And if we go into production serving, and by the way, you have access to all of this thing here. If you go to the material for this course and you go to Ballot Postman collection and you follow the lab so that you can download that directly into Postman, then you will be able to access these two utilities here. The first one that we've used to access the model when it was deployed locally, and then this new one that we are using to access the model when it is deployed online. And here's the magic of it. We now have this model or this script that is deployed online, and because we allowed everybody to access it, because we have allowed everybody to access it without any kind of authentication, we are essentially saying that anybody who has access to this URL can just like insert in here, create a post request, and then provide any hand that they want to learn about or to analyze, and just send the data. And let's see if we get some data back from this. Hopefully this is gonna work. And there you go, ta-da! This is unbelievably powerful. Like, we have created an API that we have deployed online. It means that anyone from anywhere in the world can use this API that we have created for the game of Belote Manier. And in fact, if we go back to the Cloud Functions Belote serving thing, we can see, if we refresh, we can see that our request has been processed properly. There you go. We can see that after we made some error, like trying to access this stuff from the web browser, we have tried to access it from Postman, and we can see that the prediction of the sample that we provide, well, in fact, we can see that the prediction of the sample that we provide, so the prediction on top of this sample here to come up with the probability here, we can see that this is running. These are the logs that tell us that this is working properly. And eventually we finish the prediction and we return back to the user the probability of winning. And there you go. Anyone can use your deployed model now, and you're only going to be paying whenever somebody makes an actual request, not for all the time that this is online. So that was it for today. We have learned how to deploy our model in a production environment. The model is running, the model goes and look into our production folder with Google Cloud Storage. The model goes and look in our production storage space, to serve this model, and it's pretty awesome. So I hope you had a good time, and talk to you soon.